Hey friends, welcome to our new section. I'm calling it Hack of the Day. I don't know if I'd be able to do this every single day, but at least it's a start. So, in this video, what I want to talk about is running untrusted shellcode. Now, this video is sponsored by Security Tube Trainings, so please have a look at our website. Now, here's the thing, right? When you look at shellcode, it almost feels like black magic. All of these little characters here, it's just machine code. And as one can imagine, apart from Neo in Matrix, nobody can look at this and tell you what is happening, right? So the question arises, you receive an exploit with a bunch of shellcode in it, or someone just gives you shellcode and says, hey, this is fantastic and this is allowing you to get root on a computer and whatnot. Maybe it's an exploit. So the question is, do you run untrusted shellcode? Right? How many of you do? Now, in this video, what I want to demystify is how to go ahead and logically start looking at all of this. Right? So here is what I've done. I've gone ahead and copied the shellcode, and don't worry, I would give you a link from where to get the shellcode and try this yourself. I'm using an Ubuntu machine, a 32-bit one, and what I've done is I've gone ahead and copied the shellcode into this little C file called shellcode.c, and this is a pretty standard file to test shellcode, right? What it does is you basically define a character array, you put the shellcode in, and you transfer control to that shellcode so that this shellcode would run. Now, let me go ahead and do that. I'm going to quickly compile this with no stack protector exec stack. This is simply because we'd like the shellcode to run without any hindrance, because we are really testing the shellcode. Okay, let's run it. Whoa, hold on, no. It defeats the purpose if you run untrusted shellcode, right? We wouldn't run it. So let's do some analysis. Let's open it up in GDB. Let me set the disassembly. Let me set the disassembly flavor to Intel. Now, if we look at the shellcode file, you would notice that we have everything in the variable code, which is where transfer is sent. So what we really want is, as soon as transfer goes to code, we would like to go ahead and set a breakpoint there. So let me do that. There we go, set. Let me run. Let me hit disassemble. Now, this is basically the beginning of our shellcode in its current form, right? Now, typically, the whole idea would be that your shellcode would end up doing some operation. Let's try and figure out what is happening in here. I see a jump to code plus 15, which is here. I see a call here to code plus 2, which goes back here again. And there is a pop ESI. So the shellcoder in me says, this is the jump call pop scenario, and typically you do a jump call pop to get the address of the very next instruction after the call into one of your registers, which in this case is ESI, right? So we jump, we do a call, the call pushes the address of the next instruction onto the stack, and then we do a pop in here, which means the address is now popped onto ESI. So at this stage, ESI would basically have this address inside it. What are the next two things we are doing in here? So we have a XOR ECX, which means ECX is now 0. And then we move the value 21 into the CL register, right? 21 in hex. After this, we do a XOR with a byte 7C and increment ESI. Interesting. and then we call the loop assembly language instruction, and this goes to loop plus 7, which is in here. So these two instructions in here are going to go ahead and repeat in a loop. Loop is going to decrement the CL register, and once CL goes to 0 or ECX goes to 0, this loop stops, and then we go down here to the jump instruction. Now notice that we seem to be XORing with the values pointed to by ESI, and ESI points in here, right? Which means we are actually XORing 7C with individual bytes starting at this address, and then we go further. How much? 21 hex, and we are incrementing ESI. What this means is really we are XORing every byte in here up to hex 21 with 7C. And if you think about it, this is nothing but XOR decoding which is happening, right? Once the XOR decode happens, we seem to be calling jump, which goes to code plus 20 here, which means now the decoded shellcode is going to be run. So the first step really is to figure out how the decoded shell looks like, which means let us go ahead and set a breakpoint just after the loop instruction returns, right? This is at plus 13, so let's set a breakpoint here, break star $EIP plus 13, and let's continue. We've hit our breakpoint and we are about to jump, but because the XOR decoding has finished, all the stuff in here up to basically 21 hex number of bytes has been decoded, and we can now see the decoded instructions, right? This looks a little bit more legible than if you remember what was in here, right? Which was pretty difficult to kind of figure out, right? You have a bunch of things, we have XMM registers being used and whatnot. This looks a little bit more something which we can digest. Okay, so what is happening here? Push pop XOR, we call interrupt 80, interesting. And again we have a XOR push blah blah blah, and then again we call interrupt 80, interesting. Which means interrupt 80 is actually syscall, right? We are calling some specific syscall. So really what we want to do is figure out the two syscalls we are calling and the arguments we are passing to them. So let me set a breakpoint here at this address. So this would be the first place where interrupt 80 is being called. And let me set a breakpoint for the next place as well, which is in here. Right, and then you have this instruction, but if you kind of quickly look up there, we'd actually see that this instruction remains the same, which means the XOR decoding pretty much ended here, right? You could also count the offset and figure out that it is exactly 21C. Now let's go ahead and continue running the program. Okay, we've hit the place where we are going to call the first syscall. Let's look at the different arguments to the syscall. The first thing is the syscall number, right, which is going to be figured out with $EAX. It's 46 in hex. Let's try and print this in decimal. Syscall number is 70. So let's figure out what this syscall is. Let me open a new tab. Let me open user include i386 asm unisted 32.h. Now let me go to number 70. There we are. So the syscall being called is set REUID. Interesting. Very interesting. So let me open up another tab and do a man for this specific syscall. Man set REUID. So this basically says set real or effective user ID or group. The first argument is RUID, the other is EUID. So let me go ahead and look at what's happening here. So this sets the real and effective user IDs, blah, 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 blah. On success, 0 is returned. On error, -1 is returned. Okay, interesting. So we are trying to go ahead and set the real and effective user ID. Let's look at the values we were using for that, right? Now, syscalls, which means this would be inside EBX, and basically this would be inside ECX. This is EBX, this is ECX. Interesting. So the effective UID we are trying to really set is 0. I'll leave this as an exercise. Let's see who in the comment section can tell me what this means, right? Anyway, so we are trying to set the UID, the effective UID of the process. Interesting. And set it to 0. Why? Let's see who answers that. If any of you have come this far in the video and I've already not bored you to death. And now let's move on to the next syscall. Okay. And at this point, let's look at the value inside EAX. It's 11. What is 11? Let's go up. execve. So what we are trying to do is we are trying to execute a new process, right? execve does that. Now let's look at the man page for execve. So execve takes the first argument as a pointer to the file name you'd like to execute, followed by the list of arguments, followed by the environment. What I'm really interested in is the file name. So if I look at the EBX register, we should have the address pointing to the file name, and I could easily do an examine string $EBX. And this basically says that the file name we are trying to execute is bin.ksh. Interesting. Now the problem is, let's figure out what that is. So we don't have a bin.ksh in here, right? Let's install it. Sudo apt get, install ksh, right? It's just a shell, the K shell. Okay, now let's go ahead, try and run bin.ksh. Okay, so basically all we have really is just a shell, right? And which is fair. If you think about it, most of shell code is about creating a shell for you. And that is exactly what's going to happen once we allow this syscall to go through. So let me hit continue. And there we go. We have a shell, right? And the interesting thing about execve, because your question is what happens when I exit the shell and what's going to be executed now. The best thing about really execve is execve does not return on success, and the text, data, BSS and stack of the calling process is overwritten, which basically means right now the calling process where our shell code was running no longer exists. Execve has gone ahead and overlaid bin.ksh on it, which means there is nothing else going to be executed. The program would pretty much exit if we went ahead and exited ourselves from the shell. And we can verify that. Here it is, we run. Let me put an exit, and there you go. Right? Awesome. Now, this was fantastic, right? This little piece of shell code in here took so much of time, step by step, to go through and see what was happening. Now for the source, I've picked this up from shellstorm.org. That's the URL in there so that you can try on your own. And remember to install apt-get install ksh so that you have the K shell in there, right? Hopefully things were clear. Now I welcome comments and feedback. Post your questions if you have any. I've asked one question and let's see who can answer that first. And by the way, guys, hack of the day is really for the community. post any scenarios or any ideas you guys may have, and I'll try and see if I can make videos on it. And of course, definitely help others if they have questions and see if you can answer it yourself without me having to intervene. Last but not the least, here is the shameless self-promotion. I've been running an interesting course lately, Linux Assembly Expert, where I talk about how to begin writing assembly language code, how to write shell code right from the start. We talk about jump, call, pop, and a ton of other things. It's like 9 long hours. So if your budget permits and you have any interest in this subject, definitely do consider looking at this course. I've posted 8 free videos on the course page. Please do have a look. That's all, guys. Thanks a lot. See you in the next video. Bye-bye.